All right, welcome to another exciting episode of Advanced Level Chemistry here at Spain Park. This is the new year, 25-26, but it's going to be the best one yet. So today we get to talk about the calculations for the lab. So go ahead and get out your data and the directions page, okay? And we're going to spend today and much of next week going over and doing the calculations that are required for this lab, okay? So most of everything we're gonna do, we're gonna get done here in class if you use your time wisely. Now listen, it's super important you pay attention and follow directions. I'm gonna tell you exactly how I want it set up. I'm gonna kind of show you what we're gonna do, but we're also gonna be talking about significant figures. How do we know how to round off, you know? So we're gonna do our calculations out, and then we're gonna look at how do we round off based upon the rules for sig figs, which we really haven't talked a whole lot about. So we're gonna kind of go back and forth between working on the calculations and looking at the notes and kind of going back and forth there, okay? Now, before we go even into the calculations part though, some of y'all did not get to the very last step, is that correct? Okay, so we're gonna just do that right now, but you need to add in onto your data table, you're gonna need to add in a blank because we're gonna be using a different graduated cylinder than the one that you used. So you can't use the weight. If you didn't do, we don't want that. We want this. Okay, so we're gonna come in here. So you used the graduated cylinder, all the same one for all your trials. So you only had to weigh it one time. But now we're gonna have a different graduated cylinder. So down here for glycerin, just add in here a blank where it just says mass of graduated cylinder. And then just draw, well, let's make it justified here. Draw in a blank, a line. Okay, so you're just gonna have to add that in. Okay, so all of these that you did above, you can use the mass of your graduated cylinder that you did yesterday. But for this one particular one, you're gonna have to use this mass of the graduated cylinder. If you already did this part, you just get to ignore all of this and use your data. Everybody with me? Okay, so the mass of the graduated cylinder is 25.79 grams. Now again, remember with digital, we don't have to guesstimate anything. You're all good, okay? You don't have to guesstimate anything. You don't have to, you know, put an actual zero in there. You just, whatever the digital says, it says. Okay, so now I'm gonna add the 10 mils of glycerin. So here's the glycerin. I'm just gonna go straight from the bottle, 10 mils. I'm gonna get it close. It's super thick. What's again the fancy word for thickness of a liquid?
Viscosity.
The viscosity. You got to kind of plan ahead with this one because it keeps going. I'm at 9. I'm at 9.5. See if I can get a little bit into here. I don't know if I got enough. We'll see. Okay, there's that. I'm gonna wipe this little bit that's up at the mouth off, get an accurate reading. Ooh, it went a little bit over. We gotta be exact. Okay. Will you verify for me? What do you think? Did I get the bottom of the meniscus right on the 10? Bottom on the top of the line? Close, good enough for you?
Yeah.
Okay. What do you think?
Yeah.
Yeah? What do y'all think? Okay. It's all just a blur. Okay, so now I'm gonna weigh it. Okay, so now together it weighs 38.22. So now if this is a 1 and this is a 2, and well, let's just say that this is a 9 and this is a 10, so it doesn't go above here. How many milliliters do I have in my graduated cylinder? What's the volume of the glycerin used? 10? Do I just put 10?
10.0.
Say it again?
10.00.
10.00. So what's the smallest line? Smallest line on this graduated cylinder, if this is 9 and this is 10, the smallest line represents how much? A tenth. And we always go 1 past. Since it was right on the line, I had to verify it was right on the line. That means I'm guesstimating, okay, so I know it's 10.0 something, 10.00. So that's my volume is used as 10.00 milliliters. Now, is there any difference in that number between 10 and 10.00? So why do I need to worry about putting 10.00?
To show how big, to show the scale.
To show the scale, show how accurate I measure, show that I didn't just measure 10, I measured 10.00. And when we do the calculation, that's going to help us to know, well, how accurately then can I say the density of my glycerin is? How many digits am I allowed to say to my degree of accuracy? That's the important part of that, and that's what we're going to get to here in a second. So the mass, how do we get the mass of the glycerin alone? This is actually a calculation, not a data, but since there's a blank for it, subtract these two, right? So it's going to end up being 12.21, so 43, 12.43. Did I do that right? I'm pretty sure I did. Okay, that's called mental math, y'all. You can do things in your head without a calculator, but if you want to double check me with a calculator, you can feel free to do that. Did I do it right? Okay. All right, so you can fill in, you have the rest of your data now. Okay, we all got that? So anybody that didn't get that last step done. So now everybody should have all the data for all the parts. Am I correct? Anybody missing anything? Okay, so now let's start talking about what we need to do with this and how we do that. Okay? So when we look at then what's required. So here's our results. Now we're going to notice it says, first off, must be answered on a separate sheet of paper. Must be answered on a separate sheet of paper. So we're going to start with everybody's going to get a separate sheet of paper. Step 1, read the directions. Okay, we're not just going to put this onto the lab sheet, on your data sheet. We're going to do all your calculations. Now, we're going to label our calculations. So on your separate sheet, okay? Obviously, you'll have your name somewhere at the top. You always put your name on, okay? And so then you're just going to label this, calculations. Okay, so then we're going to go 1A. Using the measurements from the ruler, calculate the volume of the metal solid. So how do we calculate the volume of the metal solid from using our ruler calculation, our ruler measurements? What's the formula? For the volume of our metal cylinder. Say that again, Joe. So the volume is going to equal length times width times height. Okay? So go ahead then and just say the volume and then put your numbers in. Most of y'all got 5 times 5 points. Now, again, how many decimal places should we have on our measurements? Okay? 2, right? Because on our ruler, each line, okay, represented how much?
0.1.
0.1, so we measured to the hundredths. So a lot of y'all, we took those solids, and it went, when we went the length, it went from there, and some of y'all got it to go to like right there. So what did we say the length would have been there? If it went from here to right, wow, this marker. Oh, man. To right there. What are we gonna say this length is? That would be 4.95. And what unit is it? Centimeters. But what if it went to right here? 5.00, right? Because if we can go to 2 decimal places here, we go to 2 decimal places here, it's right on the line, it's 5.00. So make sure that we have the proper degree of accuracy. Okay, so go ahead. So did everybody get 5.00 or 4.95 times 1.20? Did everybody pretty much get 1.20? So multiply all that out, what do we get? So if we're saying 5.2, but not, pardon me, let's say 5.00 centimeters times 1.20 centimeters times 1.20 centimeters. Give me all of the digits that you get on your calculator. What's your calculator say? 7.2? But your calculator just says 7.2, doesn't it? Okay? Your calculator says 7.2, and what unit would that be?
Centimeters cubed.
Centimeters cubed. Or cubic centimeters, however you want to say it, it doesn't matter. Okay? But, now let's get our notes out. Okay, so we're going to have our notes and this. What are we allowed? How accurately are we allowed to really say our volume is? Calculator says 7.2, but what are we allowed to say? If we look at our notes, the rules for multiplication and division, this is multiplication. Okay? The answer must contain no more sig figs than the measurement with the least number of sig figs. A chain is only as strong as its weakest link. There used to be a great show on TV called You Are the Weakest Link. They tried to do a remake of it with another lady, but the original has this British lady. She's kind of small frame, but she was so sarcastic. And when somebody, it was like a trivia knowledge show, and when somebody got voted off or they missed the show, she would just make some really kind of snide remark. And she was the female version of Simon Cowell from back in the day on American Idol. But anyway, you are the weakest link. A chain is only as strong as its weakest link. A relay team is only as fast as its slowest member, slowest runner, swimmer. An answer can only be as accurate as its least accurate measurement. You can do 2 out of 3, great. But if you messed up on the 5, but you got the 1.20s right, your answer can only be as good as your least accurate measure. Okay? So in this case, here, like when we do this, we have 3 sig figs and 2 sig figs. It's not decimal places with multiplication and division. It's total number of significant figures. This is why we have to know whether the zeros are significant or not. It's not decimal places, total sig figs. So this is 3 sig figs times 2 sig figs. So how many can my answer have? You're only as accurate as your least accurate measure. Your least accurate measurement has how many sig figs?
2.
2. It's not how many decimal places, it's sig figs. So how many sig figs can my answer have? 2. Okay, so what is this to 2 sig figs? What would this be to 2 sig figs?
2.6.
2 point, you look to the number to the right, since it's 5 or greater, you round up, so we're gonna say, I just heard it,
2.6.
2.6. Okay? So your answer can only be as accurate as your least accurate. Total sig figs, decimal point doesn't matter. So if I come over here to this one, how many sig figs are in 2.4526? 5, all of them, because only zeros are placeholders. If they're non-zero, they're automatically significant. So this is a 5. How many in 8.4? 8.4 is how many sig figs? 2. Again, it doesn't matter where the decimal point is. So how many can my answer have? Only 2. So what do I round this to? Calculator says all this. What do I round it to? How many sig figs can I have? 2. This one doesn't count. So I'm going to go 1, 2. The next number is less than 5, so I'm just going to drop it off. So what am I going to say? 0.29. So I can have 2 sig figs. Your answer can only be as accurate as your least accurate measure. Okay? So now let's come back to our calculation then. How many sig figs do I have?
2. 1.
3.
Do the zeros change how big or small the number is? What's the function of those zeros? Say what, Corey? To show accuracy. If they're showing accuracy, they're significant. So we have 3 sig figs, 3 sig figs, and 3 sig figs. So how many should my answer have?
3.
3. Your calculator does not know sig fig rules. Actually, some of the new graphing calculators, they do have actually a sig fig function in it, but your basic calculator does not. So the reality is that this can be recorded more accurately than what your calculator is showing. Because it came out to exactly 7.2, so what would be my third digit? A 0. So the reality is going to be, leave it like this, and then just put 7.20 cubic centimeter, and that's your answer. We're allowed 3 sig figs. So these rules tell me how many digits am I allowed to report my answer to without exceeding the limits of my measuring device. Because my ruler allowed me 3 sig figs, I can have 3 sig figs in my answer. Even though the calculator rounded it off just to 7.2, it's really 7.20. Okay? All right, so now the next part, we're just going to kind of keep going back and forth. The next part says, okay, find the mass of the solid, okay? Oh, wait, that's the directions. That's not the, I'm on the wrong page. Here we go, let's go B. Now, using the calculated volume and the measured mass, calculate the density. So what is density going to equal? So right now you're going to go down to B. What's density equal to?
Mass over volume.
Density is equal to mass over volume. Now you have the measured mass of your solid. Okay? You have the measured mass. And let's go ahead and right up here, just besides calculations, put what metal you had. Okay, so just so you know, because everybody's going to be different, so I know when I'm looking at this, I know which metal you had right from the start. But everybody's going to have a different mass, because you had some had aluminum or aluminium, some had brass, some had copper, okay, some had iron, okay? So you put your mass. Now when you measured your mass, how many what did you get for your mass?
71.54.
Okay, you'll have a different number here, 71.54. But the volume, everybody's volume is going to be pretty close to be the same. Now, if you use 4.95, it's going to be a little bit different. And it probably didn't come out to exactly 7.2 either. But let's just do that. Just, you don't write this down, but if you did the 4.95 times 1.20 times 1.20, what did that come out to? On the calculator, what's the calculator say? I'm just practicing rounding on sig figs on this.
7.128.
7.128, and that, nothing else, that was all of it?
Mm-hmm.
Okay? But again, how many sig figs should I have?
3.
So what would we round this one to? 7.13. So we would say 7.128 here, and then equals, and then round it to the 7.13. Okay? That's how you never have to ask the question again, how many digits do I round it off to? You don't have to follow. How many digits do I need to round it off to? You just know the least number of sig figs. Okay? So if you had this, which is 100% fine because the last digit is always uncertain, if you did this, then you're going to have 7.13 right here, and that's what you're going to use for your volume. 7.13. We will use 7.20. Okay, that's cubic centimeters. So the density is going to equal, somebody get what? Go ahead, since this is yours. 71.54 divided by 7.20. Give me all the digits. Okay, probably repeating. Grams per cubic centimeter. Now, based upon our measuring devices, do we really think that we can measure this out to the tens, hundred thousands, 10,000s, 100,000, millions, 10 millions? Can we measure this out to the 100 millions place? Do you think we measured the density that accurately? No. Well, how accurately did we measure it? Well, sig figs tells us. How many sig figs in my numerator? 4. How many in the denominator?
3.
So how many can I have in my answer? 3. So what do I say? 9.94. So the density is equal. So I want you, when you're doing this, I want you to put all the digits that your calculator puts and then round it off to the proper number of 9.94 grams. And always, 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 always have units. A number without a unit is meaningless. The units on density are grams per cubic centimeter. Now, everybody's going to get different numbers here. Okay? So you put your numbers in. I want to see with everything that the calculator says, and then round it to the proper number of sig figs. Everybody doing that? Everybody's already got yours? Guys in the back, we're good? Okay? Now, I haven't given you the right answers, have I? It wasn't on the sheet. So the next one is calculate percent error. So the copper, we used copper, we used, this is the wrong sheet. Hold on, let me find a different sheet. This is the cube study. Okay, I'm just gonna write them up here. The aluminum is going to be 2.70 grams per cubic centimeter. Copper is equal to, and you guys will get one of these periodic tables, 8.96. The iron, Fe, is equal to 7.87? 7.87. It says 7.874, but I'm just going to say 7.87. And then the brass, this tells me brass, doesn't it? It's just 8.0. Okay, so these are the actual values. So how do we calculate percent? Okay, we have all this, right? I can mute this. I'm getting my steps in. Okay? So now we're going to go to C. We're going to do our percent error. Does everybody remember what's the formula for percent error? Go back to page 1 of the notes.
Error equals experiment value minus actual value.
Your experimental value, that's what you just calculated right here, minus the actual value, divided by what? Divided by the actual value. And it's always times 100 to put it into percent. So in this case, the experimental value is 9.94. What metal did you have?
Copper. I think.
Copper, okay? So 9.94 minus the right accepted value of 8.96 divided by 8.96 and then times 100. Now again, you're going to be putting in your values, okay? But now here, this is going to get tricky. This is the trickiest one as far as sig figs is concerned. Okay, I'm giving you a chance to get your stuff written down, okay? Now, it seems like, well, first off, let's go ahead and do this, okay? 9.94 minus 8.96, that's going to be 0.98 divided by 8.96, and we end up getting 0.98 divided by 8.96,
0.109.
all of the digits. Now wait, did you multiply by 100?
No.
Okay, go ahead and multiply by 100.
10.9375.
9375% is what the calculator shows. So once again, we want to round this off to the proper number of sig figs. Now, it seems like you got 3 sig figs minus 3 sig figs divided by 3 sig figs. How many sig figs should you have in your answer? 3. But that's not exactly right. Because let's go back to our notes. We've talked about the rules for multiplication and division. But what are the rules for addition and subtraction? I'm all over the place here. I'm out of space, but we're going to figure this out. Okay, so the rules for addition and subtraction. Addition and subtraction is all about the decimal point. Okay? The last digit of any measurement has uncertainty in it. Okay, now I got stuff on the board here. I don't want to erase that. This 2 is the last digit. That's uncertainty. So there's uncertainty in the 100ths place. There's uncertainty in the tens place. And there's uncertainty in the 100ths place. But when you add all those together, that means there's uncertainty in both of these places. Because the 0 introduces uncertainty into the 7. We're only allowed to know all of the digits we know for sure plus 1 digit of uncertainty. So your answer for addition and subtraction is which number has the least number of decimal places. That's how many decimal places you can have. So in this case, this 1 decimal is the least accurate measure, so I can only have 1 decimal. So what would we round this to? 369.8. correct? So 369.8 would go right here in your notes. So when you come over here, you have 3 decimal places, 2 decimal places. So how many should my answer have? 2 decimal places, right? So what would this round to 2 decimal places?
46.2.
Okay, did y'all hear that? Your answer, so addition and subtraction is all about the decimal places. Multiplication and division is just total sig figs. 2 different sets of rules, whether it's addition and subtraction versus multiplication and division. You have to know those rules. Okay? Addition and subtraction is all about the decimal places. Multiplication and division is just total sig figs. Doesn't matter where the decimal place is. Okay, we're going to practice this all year long. Okay, but as we go through this lab, we're just going to continue just to do this. Okay, so we got that the rules there. So when we apply these to this, when I subtract, I have 2 decimal places and 2 decimal places. So when I subtract this and I follow my order of operations, this came out to 0.98 though. I'm allowed the 2 decimal places, 0.98. But now when I do the division, it's all about total sig figs. So how many sig figs do I have in my numerator now? After I do my order of operations, after I subtract. How many sig figs are in the numerator? 0.98 has only 2 sig figs. Divided by 3 sig figs, how many should my answer have? Only 2 sig figs. So what do we round this to? What's your error going to be? 10.9375 rounds to 2 sig figs to 11. So it equals 11% error. And it's a positive value because he was over by that amount. If you happen to have 8.76, then you would have, oh, I have to, nobody told me to take roll yet. Hey, hit pause. All right, so when we do calculations that have multiple functions, you have to follow the order of operations. And so if you have a parenthesis with addition and subtraction, you have to use those rules. But then what you get is your answer, that divided by here, you know, so this is the trickiest one of all sig fig questions when you have to do the subtraction, then the division. Okay? Y'all with me? Because we're gonna do this again. I'm leading you right now, just kind of showing you everything. But as we go, I'm not going to be quite as detailed with working it out with you. Okay? But we're kind of learning our rules on how to round off, kind of as we're doing it. Okay? So the best we can say is he got 11% error. Okay? Now, have some of y'all gone and done your error? Anybody get better than 11?
I got
10?
I got like 20 something.
20 something?
I got 20.
Wow.
No.
Okay? Okay? All right. So somewhere along the lines, you know, maybe our measuring or something, or maybe, who knows, maybe they're beginning to oxidize and maybe they're getting heavier, or were you over or under? Were you too heavy? Were you like this? The number was too big? Or was the number smaller? They're all too big?
Yeah.
Okay? Now notice again that if you make a mistake, we're multiplying, the length times width times height. That's one of the reasons why the mistake tends to multiply, you know, gets bigger. Because if you're only off by a little bit, but you keep multiplying by a little bit, eventually it becomes more than a little bit. Okay? All right. So now let's look at the next part in the calculations. Okay? Right here. Now it says, on this part, 2, to calculate the volume of the solid by the displacement of water. So now you're just going to go, you have a 1, A, B, C. Now you're just going to go and do a 2, A. Okay? 2A. How do we get the volume of the solid from water displacement? How do you get the actual volume? You guys know how to do this. Come on. Subtract what? the difference between your two volumes, right? You started off somewhere in the 50s, and you went up some, okay? So go ahead now and just, you're going to say 2A, so just come here right afterwards, say 2A, and I'm just going to make up some numbers that you had 57.5 minus 50.0, but we're going to use units. And you can say milliliters or cubic centimeters. You don't want to mix them. So what would that, if I use those values right here, if I use those values, what do I get? 7.5. Now, what if I had 57.0 minus 50.0? What's my answer? Okay. You want to say 7. It's 7. But it's not just 7, it's 7.0 because we measured here, so that tells me my volume is not just 7, it's 7.0. Okay? So your answer can have as many digits as your least number of decimal places. They both have one decimal. Hopefully they both have one decimal. Okay, when you measure that volume, the smallest value is a 1, so we measure to the tenths. Okay? So you get your volume. So that's super easy. Okay? So most everybody should have a volume now to here. So now it says in V, now calculate the density again with your mass over your volume. So go ahead and calculate your mass over the volume. Same mass. Okay? Your mass didn't change. Same piece of metal. Divided by the volume now that you just got with water displacement. Now I'm just going to put the 71.54 grams divided by, I'm just going to say 7.5 milliliters. And when I do it, it comes out to 9.5386666667. It's actually 6 repeating, but grams per mil. It's amazing how many times that number shows up. I'll say, and I'm going to remember this for the next class, is I'm just going to say it's repeating. Okay? But how many digits should I have in my answer based upon the rules of sig figs? 2. I have 4 divided by 2. This is my least accurate measurement, so that's going to determine the accuracy of my answer. Okay? So what do I round, if this is my answer, what do I round it off to? What do I just round this off to? Okay? How many? It's not decimal places. It's sig figs. 9.5. 2 sig figs. Multiplication and division, it doesn't matter where the decimal point is. Okay? So it's just going to be, so you write, I want you to put down, just for practice purposes, what your calculator gets, and then we're going to round it to 9.5 grams per mil. Now you could just as easily say 9.5 grams per cubic centimeter, because 1 milliliter in a cubic centimeter is exactly the same. Okay? All right. So then C says calculate your percent error again. Now using what we learned here, calculate your percent error, write down all the numbers that your calculator gives you, and then round it off to the proper number. Okay? And again, you're just going to label this as C. Right here, percent error equals. You don't have to write the formula again, just now plug in. You were under this time?
Yeah.
Okay, were you closer than 11?
0.66.
So, but you got to multiply by 100. Oh, you did multiply by 100? Oh, what did you get? What was you at? 8.9?
Yeah.
Okay, but what? Yeah, so 8.9. Now, here's something and you don't have to, but generally speaking, you try to compare apples to apples. So like if you're, on this one, you only get 2 sig figs for your answer. So a lot of times we round the actual value just to 2 sig figs. So you could say, so copper, instead of saying 8.96, what would that be to 2 sig figs? 9.0. So you could compare your 8.9, and you got 8.9 to 9.0. So I mean, much closer. But I mean, if you want to keep the 896, that's fine too. But you round off at the end. So.
Why is the percent error so big? It's not right.
It just is. I mean, y'all's measurements, just you're learning. Okay. So, 9.0 minus your 8.96 comes out to 0.04. Okay. So 0.04. So the reality is that did you have copper?
Yes, I did.
So if you take copper to 2 sig figs, 9.0,
It's because we only have
subtract it from your 9.0, what's your percent error? 0. You're right on the money.
Heck yeah.
Okay, or in this case, it's going to be, if it's 0.004 times 100, you would have 0.4% error. 0.4%.
Oh, we're so good.
0.4. But the reality is that you could really adjust, and just compare apples to apples and go 9 to 9, 9.0 to 9.0, and you have 0% error. You're acting like, there's no way that it could be right,
I was very confused with like the
decimals.
Yeah, the stuff is kind of
Okay,
like,
yeah.
it's gonna.
Well, that would be right.
Yes.
Negative is fine. That just means you were under. Okay, so what metal did you have? Iron. So you got something less than 7.87 for you. Okay. And the negative simply means that you missed it by less than rather than more than. 7.8. You're really close. So it's a very small percent here. You're right on the money. You're an A plus. Okay. No, you guys are all saying there's no way I could be this accurate. I have to have done something wrong. But no, it's right on the money. Okay. Okay? All right. So good day. Look, I told you that you're going to love these sig figs. Okay? I understand it's a little bit confusing. We're just going to continue to practice. We've gone through part A, now all the density of the solid. On Monday, we're going to come in and start looking at our calculations of the alcohol density. We're going to do more subtraction and division, those type of problems. We're going to get to graph it some. Woohoo! Get to do the graph and find the slope, okay? And do some of that. We're going to do it both by hand and on our Chromebooks. But that's all next week. What I want you to do this weekend for me is I want you to rest. It's been a long first week, and we're going to come back fired up and ready to go. All right? So y'all have a great weekend, and go Jags.